Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome to this explainer. Today, we're embarking on a really fascinating architectural journey. We're going to tackle one of the absolute most critical, yet notoriously complex, pieces of any modern web app: building secure, centralized session management. And we're going to do it using Firebase Authentication right inside a React and TypeScript application. If you want to figure out how to build rock-solid authentication without literally tearing your hair out, well, you're exactly where you need to be. But first, let's address the elephant in the room. How hard would it really be to build a secure login system entirely from scratch? I mean, think about it for a second. You'd have to manually implement all the registration flows, you'd have to write secure password hashing algorithms, manage session tokens, build password recovery pipelines, and constantly, and I mean constantly, patch backend security vulnerabilities. It is an absolute misery of reinventing the wheel, and quite frankly, it's a massive security liability if you aren't a dedicated backend security expert. Okay, let's dive into this. Here is our roadmap to demystifying authentication. We'll start with the authentication problem, meet Firebase Auth, connect our React app, establish a single source of truth, guard our protected routes, and finally, handle errors like a pro. Starting with Section 1, the auth problem, and why building from scratch is usually a bad idea. Let's really break down why relying on custom-built infrastructure for user management is often such a high-risk, high-stress endeavor. When you compare a custom backend to a managed service like Firebase, the contrast is just staggering. Building a custom backend? That means spending weeks writing server code, handling all that password hashing, managing sessions, and praying your security standards are up to date. You own all the infrastructure. You own the scaling. On the flip side, Firebase gives you infrastructure that's already built, already secure, and scales automatically because it's backed by Google. You're basically trading a tiny bit of low-level customization to get secure authentication running in literally minutes. Moving right along to Section 2, meet Firebase Authentication. This is where those weeks of grueling backend work magically transform into just a handful of straightforward SDK calls. It brilliantly illustrates the power of managed auth. Firebase handles your traditional email and password registration, sure, but it also effortlessly supports external providers. So, implementing Google Sign-In? It is simple as triggering a pop-up. But here is the absolute best part. Whether your user signs in with a traditional email and password, or they use a Google pop-up, your React app fundamentally does not need to care. Every single sign-in method returns the exact same kind of session object. The resulting interface is beautifully, perfectly identical. All right, Section 3, connecting your React app. Let's get into the practical setup. I promise you, integrating this into a front-end architecture is incredibly clean. This setup flow in the console is shockingly brief. Step 1, you create your Firebase project. Step 2, you register your web app to generate your credentials. Step 3, hop into the authentication menu and just enable email and password as a sign-in method. And Step 4, configure your environment variables. Believe it or not, that's the whole shebang. Those are the only steps you need before jumping straight into your codebase. But real quick, before we write any code, we need to talk about a crucial hygiene tip. When you get your Firebase configuration keys, you gotta store them safely in a .env file at the root of your project. If you happen to be using Vite, make sure you prefix them with vite_. Now, yes, it's true that these keys are technically public configuration values. They aren't server secrets, but they absolutely still belong in a get-ignored environment file. Don't hardcode them directly in your TypeScript files. It just keeps your code so much cleaner and makes your deployments way easier to manage. Now, what's really interesting here is the user object we get back upon a successful sign-in. This is exactly what our app is going to rely on. Just look at the data structure. You get a unique identifier string, the UID, you get the user's email, which actually might be null depending on the provider, and a display name, which is super common when they use Google Sign-In. This little object right here, this is what our app will evaluate to decide exactly who gets access to what. Which brings us to Section 4, the single source of truth. This is the core architectural philosophy of our entire setup. I really want you to let this sink in. The authenticator, and only the authenticator, should own the session. You see, there's this massive anti-pattern in React development where people let multiple different components read and write session state directly. Please do not do this. If you have several sources of truth, they will eventually and silently disagree with each other. It leads to absolute nightmare bugs. We need one single central owner. So our solution is the authenticator component. Think of this as a single piece that encapsulates every single authentication flow and manages your global user state. It exposes one consistent interface through a custom useAuth hook and React context. And because we're using TypeScript, we get this amazing safety net. If any component tries to call useAuth outside of our authenticator provider, TypeScript obviously can't catch that context mistake at compile time, but we can write our hook to throw an immediate error at runtime. It gives us an unmistakable signal that a provider is missing, completely preventing those silent downstream bugs. Inside that authenticator, we use a Firebase listener called onAuthStateChanged, which runs whenever the auth state updates. But wait, here is a huge gotcha. We absolutely must track a separate loading flag alongside the user object. Why? Well, when a user reloads the page, Firebase needs a split second to reach out to the network and verify if a session is already active. If you don't have an explicit loading state, your app just panics, assumes there's no user, and mistakenly boots them straight to the login page. We have to wait for Firebase to confirm the real state. Next up, Section 5, guarding those protected routes. Now that we have this centralized, totally reliable state, let's look at how we use it to lock down our application. We build a RequireAuth component, and you can think of it exactly like a bouncer at a VIP club. This wrapper component reads the user and the loading values from our centralized useAuth hook. First, it checks that loading state. If Firebase is still thinking, the bouncer makes you wait in line, meaning it renders a loading screen. Once loading is done, it checks for that valid user object. If you don't have it, the bouncer turns you around and redirects you to the login page. If you do have it, you're officially allowed into the VIP dashboard. And finally, Section 6, handling errors and polishing the UI. This final polish is exactly what separates amateur apps from truly professional user experiences. You see, Firebase errors arrive as objects with a specific code property. Now, we've all been tempted to do it, but showing a raw robotic error code like off/too many requests directly to a user, that is a cardinal dev sin. They have no clue what that means. Instead, a robust flow intercepts these codes and maps them to human-readable text. So off/invalid credential becomes incorrect email or password, off/too many requests becomes too many attempts, try again later. You just have to map these to clear user-facing messages. And speaking of the UI, a well-behaved authentication form should explicitly model 3 distinct states. First is normal, where the form is just sitting there, ready to submit. Second is submitting, where your submit button is visibly disabled and says something helpful, like signing in. Third is error, where a clear message pops up. Seriously, failing to disable that submit button while a network request is in flight, that is a guaranteed recipe for duplicate clicks, redundant network requests, and just terrible UX bugs. You've got to control your form states. And there you have it. By simply delegating user management to Firebase and centralizing the state in React, you completely bypass a massive amount of backend complexity. So I'll leave you with this provocative thought. Now that your secure, highly scalable authentication infrastructure can be built in a matter of minutes, what incredible features are you going to build with all those weeks of development time you just saved? Dive in, have fun, and thanks for joining this.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.